So again, remember, I told you if there's some issues, you can always go to the recording and take a look at it. All right, but I do feel a little bad because we did the odds and then there were a couple on the evens that I really didn't explain that well. So I'm going to go ahead and knock those out first. All right, Austin did a good job yesterday of looking at question number 14. All right, and saying it was a little bit different, so we went over that one. And then what I want to do is I want to jump down to question number 20, and we're going to review that. All right. Plus question number 20 is called an identity. Question 20 is called an identity. The reason why it's called an identity is because when you simplify the left side and you simplify the right side, you get exactly the same thing. All right, so a no solution occurs when you have a variable equal to itself, but the constants are not the same. All right. Now, again, looking at this problem right here, I'm going to blow it up again, and this is what I really would like to kind of see on your paper. So when we're looking at this right here, when you distribute, you get 12x minus 28 plus 10 equals 12x minus 18. Now, the highlighted yellow is because you're supposed to combine terms there. All right, you're supposed to combine terms there. And when you combine terms, the negative 28 plus the 10 equals negative 18. So now what you're doing is you're looking at this piece right here, and you're saying that 12x minus 18 is always equal to 12x minus 18. All right, because that is always true, that's what we mean when we say that is an identity. That's an identity. Now, instead of writing identity, we also say it's all real numbers, which basically means no matter what number you plug in, you will get an equal side on the left, and it will be the same as on the right. Now, if something is an identity, we can say it's all real numbers, and then here is the symbol for all real numbers. And how you make that symbol is just make one line, a second line, and you make like an R. All right, and that's the all real numbers. All right, so again, number 20, I apologize for that. We didn't really go over that yesterday, but hopefully that's a good explanation there for you. All right, yes?
Are we going to have those questions?
Yes, everything that we do is going to be tested, everything. All right, yes, Mr. Dancy. All right, so Mr. Dancy wants me to go back a little bit to number 18. Now, number 18 was interesting because a lot of people thought it was no solution, but 0 is an answer. 0 is an answer. All right, so let's look real quick. I'm going to go back to where my lines are crossed out. Hey, I'm going to go back where my lines are crossed out here. All right, and when I distribute the 4 and I distribute the 2/3, you then should be able to look at that, all right, and see that distribution. That right there, 2x minus 24 is a result of distributing the 4, and then we say the 4x minus 24 is a result of distributing the 2/3. Now remember, when you distribute the 2/3, I prefer dividing. 6 divided by 3 is 2, and then 2 times 2 is 4. And the same thing with the 36. 36 divided by 3 is 12, and then 12 times 2 is 24. That's how you're getting those numbers. And then we're just doing what I taught you as far as moving variables to the left and moving variables to the right. Okay? So, Hunter, how's that?
Yeah, that's fine.
Okay, good. Thank you. Go ahead, Austin.
I was a little confused because it looked like it's like number 20.
Yes, I understand that.
So.
But it's not, though, right?
Yeah, because of the negatives, right?
Well, because the variables don't cross out. All right? And the other one, the variable is the same.
If it was like one of them wasn't a negative, would it be the same thing?
No, because 2x is still there. There's still x's left on the board. The x's have to cancel in order for it to be a special case. Okay? Yes. 26. Let's take a look at 26 now. All right, yeah. Now, again, 26 is nice because it's a matter of you doing the fractions correctly. All right? Now, on this piece right here, I subtracted 3/4 from both sides, subtracted 3/4, and then we added 5 to both sides.
What about the 2?
Okay, and then when I add the 8 and the 5, I get the 13. The problem most kids have is, of course, they struggle with fractions, and they're not sure how we got the -7/20. The -7/20 is a result of doing 2/5 minus 3/4, creating fractions with common denominators. Yes.
Can you go to your multiplication just before you get to
For which one?
26? I got 260 over 23.
Okay, so did you see 8 plus 5 was 13, not 23?
8 plus 5 is 13. I had 13 over 1 times 20 over 23.
Okay, so you made a mistake here then with adding the fractions. 2/5 and -3/4. So let's do that. All right, so I'm gonna do 2/5 minus 3/4. So the common denominator was 20. So I multiplied this by 4 and multiplied this by 5. You do that?
8.
Right? 8 and 15.
No, I added.
Yeah, you added instead of subtract. Okay, that's good though. Okay, you're almost there. You hear me? Pretty good. Yes.
How do you know
Sienna, I cannot hear you. Come on, speak
how
up.
do you know if the subtract
How do I know the what?
subtract 3/4? Because
Because it says 2/5 minus 3/4.
Oh.
It says 2/5 minus 3/4. Okay.
A general question about like, so like if we need to switch sides, right? Oh, actually, never mind.
Listen, we got a lot of work to do.
Yeah.
We're gonna
Okay.
summarize it here real quick. What? You're interrupting me.
Sorry.
All right? I don't know what you're doing or what's so funny. Math is not that funny. All right. Here we go. What?
You know which one?
Let's look at this real quick. Did you do the distributive properly correct?
Yes.
Then the yellow is what I combined. -18 and -7 is negative.
Yes.
Is that a mistake?
Yes, I was transferring that, so
Yep.
actually
Combine first. Combine first. All right. All right. Here we go. Listen again. I have parent conference tonight, and I'm going to tell them, just like I'm telling you guys, I'm not a babysitter. All right. You have to be with me. Part of you don't understand why your grade is the way it is when I'm going over problems and you're doing something you shouldn't be doing. All right? That's what I'm telling them. All right? I don't want to put up on the screen up here what your iPad is doing, what you're doing on your iPad. It's one more task I have to do. I can't do it all. All right? Your grade is a reflection of what you're doing in class. All right, now we need to get going. All right, here we go.
This would be 0, right?
What? No, we're not there yet. Everybody take a look at 27. All right, I put this there specifically. Read it. When does 3x minus 12 equal 3x minus 12? It's an identity. The reason it is an identity is because it is exactly the same. Everything on the left is exactly the same thing as on the right. I don't want you to try to, before you start a problem, you should look at it. All right, and that's one of these cases where if you just start working, all right, you're not realizing the big picture. 3x minus 12 always equals 3x minus 12. Therefore, it is all real numbers. All right, now look up again one more time. Let's say I made this 121. Now it's going to be what? No solution. Because 3x minus 12 can't ever equal 3x minus 121. All right, is everybody understanding that process? Everybody's good. All right, here we go. Continue down. 29. Again, how do we undo a fraction? Multiply by the reciprocal. Now look, you should be getting better so you don't have to put the 5/3 over here anymore. To me, you should just be squeezing in the what? The 5/3 right here and just cross that out. Everybody with me on that? You should be there. So now we'll look at this and say x is equal to, divide first, then multiply. 21 divided by 3 is? 7 times 5 is? And then don't forget the negative 35. I can't help you on that. What?
Last night I got
10 divided by 10 is what?
the answer is 10.
That's what I'm saying. Just tell me what that means. 10 divided by 10. Shh. There you go. All right. Here we go. 31. Again, reviewing the decimal. What do I do to both sides? Add 3.75. All right. Now, again, if you're not comfortable, put down the 3.75. Cross out this guy over here. X equals 6.15. And look, if you know that, give yourself a check. All right, if you didn't know it, let's make the correction, but make a note on your iPad about your correction. Why did you make a mistake? Did you forget to line up the decimals? Those types of things. All right, here we go. I tried to trick you on 33. X equals 0. Why? Because 0 divided by negative 9 is still what? 0. X equals 0. All right, any questions? Homeschool guys, you guys doing all right? Okay, here we go, 35. First thing I have to do is what? Add 6 to both sides. Now I have 7 over 8x equals negative 4 plus 6 is 2. Now we need the reciprocal. The reciprocal is 8 over 7 crosses out. So x is equal to 16 over 7. All right. Come on, keep going. Don't give up. All right? Don't give up.
How'd you get the 16 over 7? I know you did that, but how would you do it?
What is your question?
How did you get 16 over 7?
I multiplied 2 times 8 sevens.
Yeah.
So what did I do with the 2 and the 8?
Well, oh, because 2 can wait. Yeah. Okay, I get it.
Okay, 37. All right, now, again, this is a unique situation. The division, this quantity is being divided by negative 8. So this is the rare time that instead of dividing or getting rid of the addition or subtraction, you have to do what? Multiply. So we're going to multiply both sides by 3. When I multiply both sides by 3, I get x minus 8 equals negative 12.
Plus 8.
Now, again, add 8. You should be able to tell me in your head x equals negative 4. And again, hopefully you feel like you're doing better. All right, hopefully you feel like you're doing better. All right, we're spending a lot of time solving equations. A lot. It's the most important thing we're going to do. If you can do this, then I can teach you the advanced stuff. All right, here we go. Let's keep going. All right, now sometimes kids quickly look at this and they say no solution because they see 3x and 3x, but it's not 3x and 3x because one of them is negative. All right, so again, at your note up here, variables on one side, numbers on the other, or numbers on one side, variables on the other. And I say one of the main things is try to keep the variable positive. All right, so for me personally, when I look at this right here, I'm going to say add 3x to both sides. Add 3x to both sides. Now, because I moved the variable from the left side to the right side, I'm going to have to move the constant from the right side to the left side, which means minus 8, minus 8. Now go ahead and do me a favor, cross things out so your brain is seeing it properly, cross those out. Now I end up with negative 28 is equal to 6x.
It's not identity.
No, it is not. I already said that. Go ahead. Will, what?
How do you get a minus 8? How do I minus 20? Trying to bring it to that side.
Yeah, I can do it either way. I wanted to keep the variable positive, so I moved the negative 3x to the right side this time. You with me? If you did it the other way, you get the same answer. All right, you will get the same answer. All right? So now I'm going to divide both sides by 6. Will, come on. Don't be distracted. Dividing by 6. Now, does 28 and 6 have something in common?
Yes.
So we're going to say x equals negative 14 over 3. Negative 14 over 3. All right, here we go. Take a look at 41. Same exact principle. All right, now Will, this time I still want the variable to be positive, right? So I'm looking at the negative 3x, and I want to move it over here. And then I want to take the negative 7, and I want to move it over to the other side this time. And that will allow me again to keep the variable what? Positive. I like to try to keep the variable positive. So I'm going to add 3x, add 3x, add 7, add 7. Now once again, I think it's important we show that crossed out, that crossed out. Draw your line underneath it, combine terms. 2x and 3x makes 5x is equal to negative 20. Now you don't have to put divide by 5, because everybody knows 20 divided by 5 is, don't forget the negative, negative 4. Yes, Tucker, good. Come on.
Oh, never mind.
All right, what?
I got negative.
No, no. You look up here and you say, Mr. Stroud, I am not sure why you got the 5, or I'm not sure why you did a plus 3, or I'm not sure why you did a plus 7. All right, that's what we're interested in.
How you got negative 1?
20 divided by 5. This is multiplication.
Yeah, I know that, but I'm saying.
You don't know how I got the negative 20.
No, I didn't see negative 27%. But I'm just confused because I thought it would be 140.
No, because we do 20 divided by 5, not 5 divided by 20. Right now, look right here. I'm going to show you something. For you right now, for the visual part of this, I think this is important. You hear me? Do this step. Right? And then you can see it's 20 divided by 5, not 5 divided by 20. You with me on this?
So you always divide by
The number in front of the variable. That's correct. Number in front of the variable. Now, William, do you understand what I'm saying about, I don't want to correct you. You look up here and follow, and then you tell me where you're different. Right? Then I can't follow what you did. All right? Good job. All right, here we go. 43. Okay? Now, on question 43. All right? Max, what are we thinking? Yeah, let's distribute. When I distribute here, when I distribute here. Now, again, most people distributing a negative do it incorrectly. So you're going to take a look at your work and make sure you're distributing properly. Negative 12x plus 30 minus 12 equals 6. Look up there and see. Come on. Negative 6 times negative 5. Come on, you're smart. Use your brain. Now, we're going to combine these two right here. And you're also mumbling under your breath. And you're going to stop that. Negative 12x plus 18 equals 6. Subtracting 18. Negative 12x equals negative 12. Now when you get to this step, you're just dividing. X equals 1. William, tell me. You happy with that?
I got that part right. Yeah, first.
Good. All right. Now, everybody try 45 right now. What?
Sometimes I'm confused on.
I want you to look up here on the board and say, I'm not sure why you did this. All right, that's how I teach you. I'm not making some generalization. You look at yours and you look at mine and see what's different. Okay, then we're good. Totally good. All right, now we're going to 45. All right, now why is 45 difficult? Because we have a fraction. All right, because we have a fraction. All right, give you 30 more seconds. Let's go, chop, chop. 30 more seconds, come on. Let's go, let's see how you're doing with the fractions. What? If you want to run down, I'm not ever.
My work is just so messy.
No, I know you can. Hear me? So I'm not. I know technology is a thing.
You're when you draw.
I totally understand. All right, I totally understand. Sometimes what happens to me when that happens is I turn it off.
I did in the.
I know it's annoying. So annoying. So again, I'm not. I don't care because I know you're working. Okay, if you're being lazy every day, then I'll think differently. But right now, I know you're working. All right, so I don't care. All right, something happens with these technology. All right, it's not perfect. Okay, so now, let's see, guys. Come on now. All right, here we go. Most of you guys just instinctively put minus 2/3, minus 2/3, plus 3, plus 3. If you did that, you can pat yourself on the back. That's a pretty good job. If you move the 3/5 to the right side, that's no different. All right, you're just a little wiser because you knew that 2/3 was greater than 3/5. So that's better, actually. All right, but most people right now are just trying to solve it. All right, so now let's look at it again. And like I said, make notes, all right, about where you made a mistake. What? Thank you. This goes out here. All right. This, stop interrupting now. All right, we're good. I said thank you. We're going on. All right, 9 plus 3 today is 12. Now, everybody knows we're subtracting these fractions, correct? Because one's positive, one's negative. So now I need the common denominator, which is 15. So now I'm making myself a note. 15. Now look how I figured out how to do fractions super quick. I put a 15 down with the large fraction bar. I look at the first fraction right here. Come on, pay attention. What do I multiply by? 3. So that numerator becomes a, notice I put the 9 right here. Now I look at the next fraction. All right? And I'm noticing, what do I multiply? 5. All right? And 5 times 2 is? So it's 9 minus 10. Come on, we can do that. Is everybody good?
I don't understand that.
You have to convert it.
What?
I don't understand how you got 9 minus 10 over 15.
You do what? What am I multiplying the first fraction by? Okay, so how did I get the 9? You told me how to get the 9. You did. I heard you. Yes, you did. You said 9. All right, now how did I get 10?
Multiplied by 5.
Sometimes I just don't think you're listening. That's why I'm so frustrated. All right, you talk, you're doing things you shouldn't be doing. I'm not putting up with that this year. 7th grade is different than 8th. I'm trying to prep you for high school. Get on board, or there's going to be problems. 9 minus 10 is what? So now I have negative 1 over 15x equals 12. Everybody happy with that? Now, again, fraction.
Multiplied by the reciprocal.
2,000 times now we've done it. Multiply by the reciprocal. So I'm going to multiply both sides by what? How about we say negative 15? Now you can say 15 over 1, but to me sometimes that complicates it. We're just multiplying by negative 15. You should come over here and say, boom, that's gone. So now I have x equals 15 times 12, negative 180. How did I do that? I did 12 times 10. Then I did half of that because I was going 12 times 5. That's half of 120, then I added it together. For those of you guys who don't know how to do the mental math on that, that's important. All right? So x equals negative 180, correct? All right, let's go. 47, I have to do what? Distribute. Let's go. Distribute, please. Quick, quick, quick. Distribute.
Negative 6
Good. Come on.
minus 21.
Good. Negative 6x minus 21 equals x plus 7. Thank you. See how it is? Easy to communicate, right? Without mumbling. What?
And then don't you want to give the variable?
Yes, I'm going to push the variable which direction?
left?
To the right, because I want the variable to be positive. So I'm going to add 6x. Add 6x. Then minus 7, minus 7. Negative 28 equals 7x. So x equals what, guys?
X equals 4.
No,
It's
negative 4. Thank you. X equals negative 4. Again, most of the mistakes are negatives. All right, most of the mistakes are negatives. All right, here we go, guys. Come on, chop, chop. All right, here we go. This time I want the variable which direction? To the left. That's right. Yes, sir.
2 questions. Can you scroll back up for when do you know to go to the left or right?
Because I'm trying to keep the variable positive, buddy.
Oh, so you want to keep the variable positive?
Yeah, so that way I move the negative. I always move the negative, okay?
Well, what if the variable is negative?
I move it. If it's on the left, I move it to the right. You with me? So let's look at the next one down here. I'm going to let you answer that question. Which variable am I going to move? Hey, which variable am I going to move? The 11 or the negative 6?
So negative 6.
There you go. Come on. That's what I'm talking about. That's how you listen. All right. So I'm moving this over here. I'm moving this over here. Good job. Now we're going to add 6x, add 6x, add 31, add 31. 17x equals, what is that? No, it's not. Thank you. Negative 21. Beautiful. Now, dividing by 17, again, we just leave it. Negative 21 over 17. Yes. Thank you so much. All right. Which brings me to the last problem. Look how good I am. Timed it beautifully, as usual.
You want an award, Mr. Scott?
I get an award every year. Thank you. All right. Here we go. We're going to distribute. So tell me what's 2 times 2?
4x.
Beautiful. Then now,
Minus 18.
minus 18. Thank you.
Plus 3 equals 4 minus x.
All right, I'm happy. All right. Now, what am I looking at here, guys? What is that? Like terms. What does that make? Come on, guys. 4x minus 15 equals 4 minus x. Once again, I'm going to move which one? The x to the left. Thank you so much. So that becomes a positive x, plus 15, plus 15, 5x equals 19, right? So fractions are fine. X equals 19 over 5. Yeah, I'm going to leave that there. And listen, guys. Hey, again, does everyone understand me? I'm really not grumpy, all right? I want to be here. I want to help, all right? I need your attention for a quick amount of time because I'm running here, running there, running up the steps, setting up the technology, all right? We're 40 minutes. That's about all I have with you. All right, so that's why I want to move. I need your attention for 40 minutes. All right, I'm telling you, math and English, most important things that set you up for life. All right, you want to be as good as you can at math and as good as you can at English. All right, all tests are math-oriented and English-oriented. All right, that's why I'm focusing. 8th graders are better than 7th graders in most cases. All right, in most cases. All right. Yeah, some of you guys were going backwards. I understand that. All right, that's why I'm saying 8th is better than 7th because you're supposed to be a little bit more mature. All right, some of you haven't got quite there yet, but you're working on it. And I'm going to have to correct you. And it's going to be harsh sometimes because I don't want to mess around. I've got too many other people that I'm focusing on that I have to take care of that are trying to get into high school. That's harder to get into if you want to go to Jesuit or Tampa Prep or Berkeley or Academy. Every year it gets a little bit harder. All right, so you got to be good, not average. All right, no one in here is average. No one. All right, you're as good as you want to be. All right, that's why I say tighten up and let's go. Equations, solving equations, most important. If honestly, if you can do the equations, I can really just about teach you anything. All right, so that's why this is important. So now tonight, go through and try the evens. All right, I will post the solutions after the next class so you can check all of your work, 1 through 52. Then I'm going to walk around the room tomorrow and take a look at your iPad. All right, and see how things are going. All right, please work hard. All right, I know it's difficult. All right, but everybody in here can do that. All right, so get busy. All right, Sorry I had to talk too much today, my homeschool peeps, but that's just the way it goes, all right? You guys get done with the evens. I'll post the solutions. I know you guys are listening, but you all have a fantastic day, okay? Take care, guys. Bye, guys. I appreciate you. Keep working.